In this module, we'll be looking at our first Simio model, which is built exclusively out of Simio processes. And if you're not familiar with that term at all, I would recommend that you first view the module on the Simio framework, which gives you an overview of how things in Simio work, and then come back and view this module. And so what we're going to do is build a very simple model of our single server queuing system. If you've watched the other learning series modules, you've seen this model before. Essentially what we have is a single server queuing system with arrivals at the rate of 48 per hour, service at the rate of 60 per hour, and we're going to make some standard queuing assumptions. First of all, we're going to make the assumption that the arrivals are Poisson, so the interarrival times are exponential, and we're going to assume that the service times are also exponential, and that we have a first in, first out queue of infinite length. And so essentially what we're modeling is an MM1 queuing system. And before we look at how to build the model, we know, since we have an MM1 queuing system, that we can actually calculate the standard queuing performance metrics. In particular for this model, the expected number in system at steady state is 4, expected number in queue is 3.2, and the time in system is given here in the table also. And so once we finish the model, of course, we'll come back and use this queuing analysis to verify our simulation model. So this diagram basically illustrates how we want our system to work. So essentially we will have an entity that will arrive to our system, and then we'll go through what's called the seize delay release process. The seize delay release process involves the entity seizing a unit of capacity of a resource and then delaying for some period of time representing the processing, and then releasing the resource. And so when an entity arrives, if the resource is not available, then the entity will automatically be placed in a queue to wait. If the resource is available, then the delay time will start immediately. And when an entity releases the resource, then the queue will automatically be searched to see if there are other entities waiting. And if there are, then an entity will be removed from the queue and will initiate processing. And so we also have what's called a regenerative arrival process right here. So when we have an arriving entity, we want it to create the subsequently arriving entity. And the system is characterized by two parameters. One of them is the delay time. In other words, how long are we going to process? And the second one is the interarrival time. So what is the time between subsequent arrivals to our queuing system? And if we look back at our basic model, we have entities that are arriving at 48 per hour. So the interarrival time is going to be 1 over 48 hours, or 1.25 minutes. The service time will be 1 over 60 hours, or 1 minute. And so once we have the system developed, we also want to track some of our user statistics. And so when an entity arrives, we need to do two things. First of all, we need to note the fact that the entities arrived. In other words, we're going to increase the number of entities in our system. And we're also going to record the time at which the entity arrived, which is called marking the arrival time. Similarly, when an entity departs, we will decrement the number in the system, saying that since this entity left, our system now has 1 fewer entities in the system. And we'll also record the time in system, because at this point in simulated time, we now know how long the entity spent in the system. It'll simply be the simulation time at this point minus the marked arrival time. So let's open Simio and start building the model. So the first thing we're going to do is we're going to use a resource object. And so while we're going to do almost all of the model in processes, we're going to use this one object from the standard library just to make things a little bit more straightforward. So I'm just going to grab resource 1 and place it here in the model. Then I'm going to go to the processes, and when I go to the process window, again, make sure you're associated with the model. I don't have any processes, so there's nothing yet defined. So I'm just going to click on the Create Process button in the ribbon, and it gives me process 1. And so one way to think about a process is it's a way to specify a sequence of steps that occur over simulated time, and that possibly create additional steps, and possibly change the system state, and possibly record statistics, and so on. So if we go back to our process, we have a look at what our process is doing. As we know, we want to have an entity arrive, then we're going to go through the seize delay release, and then we're going to depart. And so I'm going to defer the arrival process for a minute, and we'll come back to that. And what we're going to do is just jump in and put our C's delay release steps. C's delay, where's my release steps right here. And so now we have sort of this basic process that we have outlined here. The things that we don't have yet is, again, I'm going to come back to the arrival. The depart, we don't really need to have a depart since the process terminates immediately after the release. So now, but let's go back to the arrival process, and we said that what's going to happen is we want this regenerative arrival process. And so the way we're going to do that is we're going to simply create what's called a timer, and then we're going to make sure that this process occurs whenever the timer goes off. So what we'll do is we'll set the timer to go off for our interarrival time, and then when the timer goes off, that will trigger this process to occur. And when the process occurs, of course, we're going to start with the C's delay release logic that we just discussed. So to create the timer, I need to go to my model and go back to my definitions, and I want to create a timer element. Right? So we click on that, and then I'll just change the name and call this IAT timer, and I can then specify the properties. And so the properties, I can do a time offset, which is when is the first event going to occur, and then an interval. And so of course what I want for my M1 queuing system, I want to have this be random, exponential, 1.25, and then change my time units to minutes. And so what this does is it creates a timer that will raise an event at time 0, then sample a random variable according to this distribution, and then raise the event the next time when that time occurs, and so on. And so I'm going to go back to my process, make sure I select the process so I can see the hatched lines here, and specify the triggering event name as the interarrival time or IAT timer event. So when that event occurs, this process gets initiated. So now I can go in and specify some parameters or properties of my steps. And so the first thing I want to do is say, well, what is it that I want to seize? Well, I like to seize the resource object instance that we created initially. So I'm just going to, oops, didn't catch that. I'm going to seize resource 1. Then I'm going to delay for my exponential 1 minute. So this is just going to be random exponential 1. Change that to minutes, and then release the same resource that I seized. So I will go and let's seize resource 1. And that completes the basic logic for our system. So at this point, let's go back and let's run our model. So what I'm going to do is I'm going to set a run length. Let's just randomly say I want to run for 100 hours. And I will just click run. And so I run, and we can see down here that we are running. Of course, we don't see anything because we haven't used any of the objects for the standard library that model the entities arriving and moving through the system. But we can see that our resource is changing color, representing state changes where the resource is idle and busy. So we'll just fast forward here because there's nothing interesting to see. And now that we get to 100 hours, we can look at our results. And we see, first of all, if you've done any modeling with the standard library, we see a much smaller set of results. In fact, all we really see are the results provided by the single object from the standard library that we used, the resource object. And we see that the average scheduled utilization that we got for our interactive run is 79.67, which we know the value at steady state is 0.8. So at this point, we're pretty satisfied with the model as we have it. The next thing we'd like to do is add 2 additional performance metrics that we typically use with queuing systems, one being the number of entities in the system at steady state, and the other being the average time that an entity spends at at steady state. So I'm going to stop my model and go back to the processes view. And before we look at how to do that, I want to make one quick comment about what's going on here. I've sort of thrown around the term entity kind of casually so far in the video. And when I say entity so far, what I mean is entities in the queuing context. So we have entities arriving, seizing capacity of the server, being delayed, and so on. I don't mean entities in the Simio sense, where we're taking an entity object from the standard library. Processes work with something called a token. And so basically what happens when the process is initiated, in this case when the timer event happens, Simio creates a token, and that token executes the process. So the token goes to the seize, and if the unit of capacity is available, it migrates to the delay, otherwise it sits in a queue, and so on. So we're actually, although we occasionally say the word entity, what's really happening inside a process is that you have tokens that are created executing the individual steps in the process and then being destroyed at the end. And so what we need to have if we want to get the two performance metrics that we talked about, the number in system and the time in system, and let's do those one at a time. And let's start with the number in system. So if we go back to our diagram here, you can see that in order to track the number in system, I basically need to increment a value when an entity arrives, and then decrement a value when the entity departs. So the thing that we're going to increment and decrement is a model state. So we have to define a custom model state to hold the number in system, and then we will assign the value here when it arrives, and then we will assign the value here when it departs, and then finally we will tell Simio that we want to track a state statistic based on that model state. So let's look at how to do those steps. I'm going to go to Model, Definitions, States, and I want to create an integer state, and I'm going to call my integer state num in sys. Num in sys, obviously standing for number in system. And so I'm going to go back to my process, just grab an assign step and place it right here, and then add the state variable that I'd like to update, num in sys, and I'm going to increment the value. So I'm simply going to assign the value num in sys, the current value, plus 1. Then I'm going to take another assign step here at the end once it's been released, and I'm going to do the opposite, num in sys. This time I will decrement the value, num in sys minus 1. And so now, assuming we've done this correctly, at any point in simulated time, the model state called num in sys should have the exact number of entities that are in our system at that time. So now the final step that we need to do is go tell Simio that we'd like to keep track of that value. So I'm going to go back to Elements, and I'm going to create what's called a state statistic. And when I do that, it says, okay, well, what is the state variable that you would like to track? And of course, I want to track the one that I just defined, which is num in sys. And then I'll go ahead and rename this. Let's just call this number in sys. Let's go ahead and say system, number in system. So now I have a state statistic called number in system. And so what happens is when an entity arrives, I add 1 to it. When an entity departs, I subtract 1 from it. And then Simio will keep track of that value over time. And so we can now go back to our facility view. Let's reset our model, and let's run again and jump into fast forward mode. We get to 100 hours, and now we go look at results, and now we have a new statistic here. We have a new value, which is a user specified statistic, number in system, and we have the average value, the final value, and the maximum value over our interactive run. The last thing we need to do in our model is add the final statistic, which is the time that the average entity spends in the system. So to do this, what I need to do is I need to first define what's called a tally statistic, which is in Simio talk, an observational statistic. Then I need to mark the arrival time, as we have shown here, that when an entity arrives, we mark the arrival time. Then when the entity departs, we simply record the time in system, which will be the current simulated time minus the time that the entity arrived. And so note the difference here, or one of the differences here, is that we can't use a model state. We can't use a model variable because in this context, each entity or each token in the context of a process has its own arrival time. So if I have 10 entities in the queue, each one of those corresponding tokens will have its own arrival time. So luckily I don't have to, for this model, mark the arrival time because Simio provides that information on when a token is created with a token state automatically, which we'll see in just a second. So what I'm going to do here is first go define my tally statistic, go to my definition, elements, and tally statistic. And the tally statistic I'm going to call time in system. And then I'll tell Simio that this is a time that I'm going to record observations of time. And so again, as we said in our flow, the first thing that we do is mark the arrival time. And Simio, as I said, does that automatically. So what Simio will do is when it creates a token, it will record that value. And so the last thing we need to do is just record that observation. And so we do that with a tally step. So I put the tally step in and I say I want to add an observation. So think of a tally as a bucket of observations. And when I hit a tally step, I'm going to compute a value and then toss it into the bucket. And then at the end of the run, Simio will take all of the observations out of the bucket and perform compute some descriptive statistics on the group of values. So we say we want to do the time in system. The last thing we have to do is say, well, what is it that I want to record? And so here's where we're going to do the token. So I'm going to token, and we have this nice state called time created. So this gives me the token time created, and we're going to subtract that from run time now. Probably would have been easier if I'd have just done runtime now first, but I had already started typing the token time created. So what we have is we're going to take the current simulation time and subtract from it the time that this token was created. And so that corresponds to the recording of the observation. So we go back to our facility view and we reset our model, and we'll run it in fast forward mode, and we come to our results, and now we have a new element in our results for time in system. And for this interactive run, we can see that the average was 0.028 hours, which is relatively close to what we expected. And if we go back to our results, we can now compare let's see, there we go. We can now compare the results that we got from our single interactive run of our model with our queuing results, which we know are exact. Of course, with the model, we ran a single interactive run. We didn't run multiple replications. We didn't warm up the model to account for the transient period. And those are things that you should definitely do before we would put any credence in our values, but those are both topics for another video. So let's just summarize what we did to create this model. So basically we created the resource, then we created the process and added the steps for our basic single server logic, where we have an arriving entity, seizes a unit of capacity of the resource, delays for some period of time, and then releases the resource. We used a timer to do this self-regenerative arrival process. And to track our two statistics, we used the assign module to increment a value of a model state, modeling number and system. We used a second assign step to decrement that value. Finally, we used an observational statistic, or a tally, to record observations of time and system, and then we have the associated tally step. And so you can see that using Simio processes is fairly low level, especially relative to using the standard library, but it's also quite powerful. And also, as we'll see in future modules, all of the standard library objects are in fact built with processes, and so they turn out to be quite useful, even in most contexts where we won't build the entire model using processes, but we will either modify an existing process or just use processes to kind of add on behaviors or modify behaviors for the standard library. But again, that's a topic for another module.